plugging away at your homework quiz or whatever, finish those up and into the green folder you go if you haven't done so already. So I want to just kind of walk through the test 3 description that I put up here on my Notre Dame. So 2 parts. The first part is the no calculator piece. This one is going to contain 5 problems and 2 multiple choice or multiple part free response questions. The multiple choice questions are going to be the calculator portion this time, so we're just moving things around a little bit. So there'll be 8 multiple choice and 1 multiple part free response question. So I think originally that was like 7 and 10. In light of what happened last time, I tried to shave a little bit of time off of the test so that we don't run over again. We'll see how it goes. Again, I had to rewrite all this stuff from scratch. So last year I feel like I had it dialed in pretty decently as to not running over, and now I lost all of my files, so it's starting over again. I'm like just kind of looking at this and guessing from what I had last year. So skills that you should be able to demonstrate. You should be able to take the derivative of a function involving combinations of derivative rules, including but not limited to product, quotient, chain, trig, exponential, logarithmic, inverse trig. All the trig rules to this point. If you don't have those stone cold memorized, get it done. You know, like take some time in the next 3 days and like spend 20 minutes or so 3 times and get those in there. Don't learn them so you know them for the test. Learn them so you know them forever. Learn them so you know that your children will know them. Okay, that's how well you need to know these. They don't go away. They'll be present from here on out. You'll be glad that you have them stone cold memorized. And when I ask you what's the derivative of sine inverse, you can tell me exactly it's x over 1 minus square root of x squared.
The only stuff like that we need to know is on your review Quizlet, right?
So the Quizlet, I think, contains all these options, yes. And that was going to be my next thing I was going to remind you, is that I did have the Quizlet for you guys with the derivative rules in it. If you are a digital flashcarder, that's a good one. Now you still need to be able to use these, but like if you don't have it memorized, what are you going to do, right? Like, got to start there. You should be able to use your calculator to take the derivative of a function at a point. I think we showed you guys how to do that a couple of different ways on the calculator last time. You should be able to calculate the derivative of a function, calculate the derivative of an inverse at a point. That was the 3-4 bonus. We looked at doing some of that. Right, I had some bonus questions in here. If you did if you look at the review multiple choices, there's several in there also. Should be able to find the derivative using implicit differentiation. Find the second derivative using implicit differentiation. Ooh, scary. Sometimes it is. Write the equation for a tangent line to a point for an implicitly defined curve. Find the linearization for a function and then use that linearization to approximate values of f and give an error for the approximation. And then, things you should be able to, should look at that would have been models for problems that I looked at when I wrote the test. Is there any follow-up specifics to the things that I listed here that you're like, I just don't know what he means by that? Paulo.
Do you think that multiple choice after few have all of these concepts in those questions?
Yes, I would think so. But we're going to do some I'm going to just write up some specific example stuff here in a few minutes to kind of run through. Probably the biggest component or the biggest representative is, can you take derivatives of stuff? Right? That's going to be, 2/3 of the test is just I give you a function, can you find the derivative of it? right? Can you apply the derivative rules in the correct context? And that's a big piece of what we're doing right now. And I will be honest with you here. Some of them will be kind of mean. Some of them might be kind of mean ones, where it's like, oh, that's a chain rule inside of a quotient rule inside of a product rule that involves like logarithms and exponentials and inverse, like there's gonna, like some of these might get complicated, okay? But let's do some examples now that I think are of like similar levels of difficulty. Just so you get a good picture of like, yes, Mr. Gulick, how well do I really, like, how hard is this gonna be? So I just know, right? That's super helpful. Yes? All right. So let me make a one dated for today. And I'll do this for a few minutes, or as long as you're like, this is super helpful, keep doing this. And then we can break and take questions from you guys if you have stuff from the multiple choices or whatever. Or I might jump around and grab some multiple choice questions that I think are particularly representative or something. All right. So here are just some examples here. So this is just like doing derivatives. Find the derivative. So if I have cotangent inverse of x 3 to the x, when you look at this, first thing you should look at is there any simplification I can do to make this problem any simpler? There is not, right? No like terms to combine, no way to reorganize this. This is what it is, right? Okay. Next thing you'd look at is what trig rules are going to be involved here. So you're looking, the things you're looking for are chain, quotient, and product. When you look at this, what do we see? Chain and a product. Okay? Which one is the outermost piece? Is it a chain or is it a product that needs to come first? Chain should come first because the product is inside of the function, right? So we'll start with the chain rule. The chain rule is the derivative of the outside. What is the derivative of cotangent inverse? You mean -1 over 1 plus the square root of x squared, right? But when we say x squared, we really mean inner. Everybody's okay? And then we have times the derivative of the inner. So far, so good? Is that okay? If it's not, you should say something. You're just staring at me blankly, and I don't know if this is okay or not. Michael?
You say that's square root.
So if it's sine inverse, I think it's 1 over, or x over square root 1 plus x squared. Cotangent is -1 over 1 plus x squared. So the x is inner, right? If it's a chain. Does that feel okay? All right. So to do the derivative of x 3 to the x, we have a product rule. So I'm going to have x times the derivative of 3 to the x plus 3 to the x times the derivative of x, right? So what's the derivative of 3 to the x? Three to the x, natural log of 3. Okay? again, I'm just trying to illustrate to you, like, these derivative rules are all going to be like mashed together in one single problem, right? Everybody's okay? So again, the rule is just a to the x ln a. And then the derivative of x is just 1. Thank you. And here the calculus is done, so you should stop. You do not need to try to combine any like terms. You can if you so choose, but if the calculus is done, you can stop unless it's a multiple choice question that has like A, B, C, D, and you're like, my answer doesn't match any of those. You might have to keep going to simplify your answer to make it look like it. Nate.
So when you have a question that's like, you have like a chain rule, you have a product rule, like how do you know which one to do first? Because I never know which one.
Okay. So if I look at this, the product rule is here. It's inside of this function, right? If this instead was x times cotangent inverse of 3 to the x, now the product rule is coming first, and the chain rule is like inside of the product rule. Does that kind of make sense as to what way you're looking at this?
So can you compare it?
So what you want to do is think about it like order of operations, right? So like you're working from the outside of the function in. So here, if I'm looking at the whole function, the first thing I have to deal with is the multiplication. That means product rule comes first.
So always go outside.
Mm-hmm.
For like every single.
I think generally that's probably going to be your best bet. Yeah. Is that helpful?
Yeah.
Did everyone else get what Nate was asking and my explanation was acceptable? Okay. Should we do another? Okay. Well, I should fix this so that when you go back and look at it, that's in the right place. You'd be fiendishly confused if I left that. All right, let's do a nasty boy here. All right. If we look at this one, what do we see? How many chains, though? 2. Are they linked, though? No. Okay, so I see 2 chain rules, one for the cosecant, one for the logarithm. They're separate, though. They're not nested inside of one another. And then there's a quotient rule. Which one comes first? The quotient rule. That's the outermost thing. Okay? And then while we're doing the quotient rule, when we encounter derivatives as tops and bottoms, then the chain rule will come in, right? Everybody's cool? All right. What is the formula for the quotient rule? Just say it in terms of tops and bottoms. Yeah. Oops. So again, notice that while I'm doing this, I am writing out like kind of one step at a time, right? So like doing the quotient rule. Now I'm not doing anything else along the way. You could, but like do it at your own peril or whatever.
Could the calculus be done there?
No, because if you look, I still have derivatives to take, right? So that I need to clear those derivatives before I can be finished. Everybody's okay? All right, so if I look at the first derivative remaining, what's the derivative, or how do I do the derivative of cosecant 2x minus x squared? Chain rule. So the outer function is, okay, what's the derivative of cosecant? That's for cosecant inverse. There you go. But here the x is the inner function, right? And then we still have the derivative of the inside. I'm going to make that like a bracket just so it's easier to see with all the parentheses there. Is everybody okay with what we did there? Yuck, Mr. Kulik. Then we have this piece. How do I do the derivative of log base 2 of 3x squared? It's also a chain rule though, right? So it's the derivative of log base 2. 1 over x times 1 over the natural log of 2, right? But when I say x, what do I really mean? Inside, right? I'm going to zoom out here for a minute so I can write the whole thing. Is the calculus done here? No, why not? I still have 2 derivatives to take. So the last step is going to be doing those last 2, which are easy peasy. It's just, power rules. Is everybody okay? As long as you're being like careful and systematic and just do like one rule at a time, even if it's messy because I don't care about the simplification, it's just a matter of like keeping track of everything and being neat, and it should be okay. You know what I mean, guys? If you know your derivative rules, which we know that we need to like really bone up on here a little bit because it seems like we're a little shaky there, and that's okay. What do you guys think? Is this helpful to see like how complicated this I could ask you to be here? Okay. What do you think? You feel okay about at least what the expectation is? And other than these being really nasty, they're not significantly different than the things we saw in the last practice packet that I gave you. They're just, instead of like working out to simplify to something like reasonably nice, these could be just disgusting. But don't waste a bunch of time trying to simplify. When the calculus is done, you've finished all the derivative pieces. Just leave it the way it is and I'll figure it out. Everybody feel okay? All right. I also want to look at some of the some stuff from the test practice problems I put up. So let me grab that. All right. So this is a free response question from that I put in the test practice problems. So you should recognize this as like an implicit differentiation problem, right? To find dy dx, what do I start by doing? Derivative of both sides, right? Everybody feel good there? What's the derivative with respect to x of negative 8x squared? Negative 16x. What's the derivative of, with respect to x of 5x squared? Product rule. Yeah, product rule. So 5x ddx of y plus 5y ddx of x. What's the derivative of y cubed? There you go. Don't forget those dy dx's. So far, so good. We still have two derivatives to deal with, though, here and here. Let's finish that up. The derivative of y with respect to x is 1 dy dx, or I'm just going to skip writing the 1. What's the derivative with respect to x of x? 1. I'm not going to bother writing it. Feel okay? What do I do now? Okay, get the stuff with the dy dx is on one side, everything else goes to the other, right? I'm also going to factor that dy dx off, the two things that are remaining there. Look okay? And then we divide both sides by the 5x plus 3y. Or, sorry, 3y squared. There's my first derivative. Everybody's feel decent here? If I ask you to do the second derivative now, let's just say I asked for that also. What would I have to do? Quotient rule. So this problem doesn't ask for this, and I'm going to warn you right now, it's going to be like, the answer is going to be just disgusting that you don't want to have to deal with, but we're going to do up through the calculus so you can kind of see what's going on. I think the one that I've designed for you is not nearly as gross as this one is going to be. Because second derivatives can, like, especially implicit, can get really nasty. I tried to make one that was not going to get, like, absurdly nasty. I think I was successful. We'll see what you guys think. It's not as bad as this one. Okay, so there's my quotient rule, right? Okay, so what's the derivative of 6x minus 5y? Or sorry, 16x minus 5y. (16 minus 5 dy dx). Okay. And then what's the derivative of 5x plus 3y?
Wouldn't it just be x?
Oh, yes, thank you. You said it, I said it, and I wrote the wrong thing. Thank you, yes. What's the derivative of 5x plus 3y squared? And the denominator. Am I done? No. Alex says no. What do I still need to do? I don't need to get dy dx by itself, but I do need to substitute in what dy dx is. So my last step would then just be replacing those dy dx's with that fraction, which is like super gross, Mr. Kulik. That's a disgusting, mega complicated looking answer. I know. Oops. But because I don't expect you to simplify this out, you could be done at this point. Like, leave the compound fractions in there, like nothing. You know, you will not be penalized for like not simplifying anything. Don't go crazy trying to simplify things. Don't waste time on the free response is trying to simplify things. When the calculus is done, just stop. The piece that I wanted to illustrate here is remembering that you have to substitute the first derivative back in for the second derivative when you're making your second derivative. Is that okay? Yuck, Mr. Kulik. No, guys, I know. All right. So this was like bonus. All right. Part B says, write the equation for the tangent line to the curve at the point 4, -1. So to write a tangent line, I need slope and a point, correct? I have the point. The slope is going to come from the derivative evaluated when x equals 4 and y equals -1. So I'm going to have 16 times 1 minus 5 times, 16 times 4, 5 times -1 over 5 times 4 plus 3 times -1 squared. Right, whatever that number is. And then you just do y equals m times x minus 4 plus y. Right, whatever that number is. Everybody's okay with that? Does that feel so far? Yeah? Decent? No big deal? What happens if I had just, instead of this, what if I just told you like x equals 4? How would I get the y? You have to plug the x in up here and then solve, right? Or if I gave you just the y, you have to plug the y up in there and solve, right? Now, on your test, this one you'd have multiple answers for either x or y. You'd have multiple points to deal with. On your test, I would not give you a situation where you get multiple answers. Right? If I plug the x in, I'm going to have a cubic equation to solve for. I'm going to get 3 answers out of that, potentially 3 real answers. If I had given you the y, I'd have a quadratic equation to solve. Again, you get potentially 2 real answers out of that. On your test, I would not give you a situation. If I didn't give you both points, I would not give you a situation where you can have multiple answers, right? Mr. Kulik would not be that cruel to make you write like 3 equations for tangent lines or something, which is just like, Mr. Kulik, you're killing me here. All right. Part C says, is there a number k so that the point 4.2k is on the curve? And then using the tangent line for k, found in part B, approximate the value of k. What are we going to do for this? So let's do this to start, right? So how would I do that? I just do that, right? K should be approximately plugging 4.2 into my tangent line equation from part B. Everybody's okay with that? Yes, John? Sure. The second piece says oh, it says there is, not is there. That's a reading wrong by my part. Part D says write an equation that can be solved to find the actual value of k. So what am I going to do to figure that out? going to use this. Yes, sir.
So for C, calculating, like when it says it's on 4.2 is on the curve, it's talking about on the tangent line or on the original equation line.
It means it's talking about on here, but it says using the tangent line found in part B, approximate the value of K. So I'm doing like a linearization, like a 3-10 problem, where I'm approximating the value on the curve with my tangent line.
So all you're doing is
Plugging 4.2 into my answer for B. That's all I did. Does that feel okay?
yeah.
Now, yes.
When you're doing like, if you're taking like that, like the negative 8x squared, how do you get the derivative of the 5xy?
Product rule.
Oh,
All right. So in D, it says we're actually want not just the approximation, which we found in C, we want to find the actual value. So it asks us to write an equation that we can solve for K. What I'm going to do is I'm going to take this and I'm going to plug 4.2 in for X and K in for Y. That's it. Everybody's okay there? E then says solve the equation found in part D to find the value of K. What type of an equation are we left with here? Cubic. Is there a closed form formula to find the roots for a cubic? Not that you guys know, right? So if this is a no calculator problem, it means it's going to have to factor. So the way I'm looking at it is I would expect if I take the constant term and like add it to both sides, it'll cancel out whatever's left on the other side to give me 0. So I can just factor it nicely. If it's a calculator problem, all bets are off. If this is a calculator problem, what's my go-to method for solving? Graph it and find the intersections or the x-intercepts, right? That's what I would do here. So I would graph, well, I would probably add the 149 over and then graph it equal to 0 so I can just look for x-intercepts. That's what I would do.
You just plug in X or K.
Exactly. Yep. That's exactly right. Does that feel okay? Finn, you're making some faces. You got it?
No, I was just thinking why not Y?
Oh, yeah. Yeah. They called it K, so I just put the K in.
How would you solve this? How would you graph it for 0?
So I would just add the 149 to both sides, graph it, and then I'm looking for the x-intercepts.
Okay, so
Because now I know where to look instead of having to jigger my window to find like all the way down to negative 149 to find the 6 and 1/2 dozen the other.
yeah,
It just means less window
okay.
searching.
So like, so you would add 149 and you would set that equal to Y.
So you have like, I would type in negative 8 times 4.2 squared plus 5 times 4.2 times x plus x cubed plus 149.
Okay.
And I graph that and I look for the zeros, the x-intercepts. Or you could graph y1 is the left-hand side and y2 is the right-hand side and look for the intersection. That's fine too. They're doing the same thing.
Okay.
Alex.
on the test overview, there's no 3%. So is 3.7%.
No, not expressly. I mean, like, I guess maybe in a multiple choice type setting, right? Like I think on the multiple choice we had like speeding up and slowing down, like particle thing.
Yeah.
That would be kind of where you might find it. So I didn't put anything from 3.7 because I don't have like a free response problem like any of those. It'd be like a multiple choice one that we've looked at, I think, before. Does that feel okay?
Yeah.
Okay, good question. Okay. This is, I have one more thing that I wanted to point out from the homework or the test example stuff. I'm not going to do the whole problem. I just wanted to talk about one part of it because when we talked about local linearization, we didn't talk about this. Let's see. Is that the one? Sorry, grabbed the wrong one. 1 second. Okay. All right. So this is about like snow accumulating or something on like an open field. The part that I want to talk about is this one. So it asks us, is the approximation that we're making, so we're doing like a linearization and using that linearization to approximate the value. It's asking us, is this an over or underestimate? Now here's the catch. In this problem, at no place are you given the function for s. So you cannot compute the actual value and compare it to your estimate. So the way that you need to do this is from this given piece of information, the problem. The fact that S is concave down. What does concave down look like canonically? It's a parabola opening down, right? So this would be what S would look like. If I draw a tangent line to S, and I say I want to approximate like this value, what am I going to have? Is it going to be an overestimate or underestimate? Well, the blue is the approximation, and the red is the exact. So it's an overestimate, right? If it was concave down, and we do the same thing, what do I have now? An underestimate, right? So in terms of a problem like this, and they ask you to justify your answer, what should you do? Sketch a picture to justify it, right? Like if S is concave, down, it looks like this. If I draw a tangent line, anything on the tangent line is greater than or equal to the entire curve of S, so I have an overestimate. And you'd make the reverse argument if it was concave. Michael.
For the AP test, how you say like in the FRQs, calculus is done stop. Like is that a thing just for you, or is that actually how it's done?
That's how the AP is scored. So on the AP exam, you are not going to lose credit for simplification at any point in any free response question, unless the directions say like, show this is equal to this, right? Unless it says that, then your simplification does not matter. Does that feel good? It's nice to know, right? Important distinction, because to be honest with you, if you had to simplify things down, there's no way you'd be able to finish. Like you need the time to think and not like mess around trying to like get things as pretty as you possibly can. And the points are assigned to the problem specifically for like, like you knew to do this, you knew to do that, and then you got the answer. There's like check marks that you're looking for when you're grading it. And the simplification does not matter. If it's a calculator question, like you just need the final. And even in some of those cases, you don't even need the final. If you just have like the correct numbers plugged in and you didn't finish it, you're good. On the no calculator section in particular, if you have the correct numbers plugged in, all that's left is to crunch to get a final answer. You need to crunch them. The correct numbers are plugged in the right spots. Stop. You don't need to finish. Okay. Violet.
I know you said you were going to do, but how would you do A?
So I have a table of first derivatives. right? So So 10 would fall in between these. So it should be approximately the first derivative at 12 minus the first derivative at 8 over 12 minus 8, just slope. And the answer there would be in like centimeters per hour. And it would mean that like the rate of snowfall is changing at, you know, whatever centimeters per hour. So you have to say the rate of this is changing. So you have to have like a rate of a rate. Because that's what a second derivative is. So you have to have that. Yeah. You know, like first derivative is a rate of one thing, second derivative is a rate of a rate, third derivative is a rate of a rate of a rate.
So on.
Yeah. But that's the idea. That feel okay? And we've done that problem basically before, right? But it wasn't a second derivative, it would have been a first.
Yeah.
But again, the second derivative is just the first derivative of the first derivative. Which is like, okay.
It's fun. It's just like, yeah.
Yeah. Okay. Do you guys have specific stuff for me that you want to ask about? I tried to pick out things that I thought would be particularly helpful to see examples of, to like make it explicit, like how much detail this is going to look and how nasty things could look. Don't get freaked out by nasty since I don't ask you to simplify. Elena, we'll go with you first. This one? What? This one right here. Huh? Oh. That thing that I circled should be your final answer. The step after it is if I ask you to do the second derivative, because I put that on the test, like the test directions. I ask you, like, can you find the second derivative of an implicit thing? So I wanted to do an example of that. So I just took this one and kept going. Paula.
Can you do number one in the packet, like the test 3 MCQ?
Yes. Actually, let me just grab it from here. So you're asking for this one, right? Okay. Shh. So the linearization at x, the formula is, or well, let's say at x equals a is going to be f prime of a times x minus a plus f of a. So in our case, that's going to be 4 times x minus 5 plus 3. And then I'm just plugging 4.8 into that and getting a decimal. Jeepers creepers. So what's that come out to be? 2.8, I think? No, 3.8. Right? 0.2 times 4 is 0.8 plus 3 is 3.8. Happy there, Paulo?
Yeah.
Nate?
I didn't know the equation.
Yeah, so it's just like this is just equation of the tangent line. Same as the tangent line equation. Right? So it's like the symbols, it's different. No, it's just a tangent line. Nate, you had one?
Yeah. Really like brief rundown of like things we have to know.
So have to know your derivative rules. So I made a Quizlet with, I think, all of them in there. Things that you also have to know. Previous things that you had to know. So like intermediate value theorem. Probably still should have that. Okay. I don't think I have any limits on here, but on the AP exam you'll have to have limits still, and they could creep up, but they don't have any limit stuff on here. You probably need your tangent line equation, but it's just the equation of a line, right? Right. It's y, y minus y1 equals m times x minus x1, where m is just the derivative. I don't know, all the stuff you've learned before in mathematics, like basic algebra skills, like how to solve a quadratic or how to solve an exponential function, like all that stuff might come up. Probably won't, but like is a reasonable expectation of the AP that like any previous algebra skill you still have, like unit circle you still have up here, like you do tangent of pi over 4. So I will tell you that I don't have that stuff on the test because I think it's a waste of time. Like it's a time suck for me to put something like that on there. The AP doesn't. Like tan of pi over 4 is 1. That should come out quick. Cosine of, pi over 6, square root 3 over 2, those should come out quick. That stuff can come up. I'm just trying to be real, right? You asked me like, what do we have to know? Should know when a derivative does or doesn't exist, right? The differentiability implies continuity, but the reverse is not true. I'm trying to think of the other big stuff we've done to this point. You won't need squeeze theorem because there's no limits. I'll tell you that, but like that doesn't go away. Next chapter limits come back again. Or next test. It says that if I have a continuous function and I know that I have the y values a and b, then any y value between a and b, I can find an x so that f of that x gives me that desired y value. It basically means like if I have this, any y value in between, like there's some point on the function that has that y value, right? Yes?
Shouldn't that be 2.2 because it's 4.8 minus 5? Should be negative 0.8.
Oh, yeah. Thank you. There you go. 3.8, I felt wrong when I said it, but I convinced myself because none of you guys objected. Thank you, Lucas. Excellent. Again, I was going to stop without even pointing out what the answer is because it's just calculator at that point. But yes, thank you. Paulo, go ahead.
Can you do 18 real quick?
Same set of problems? Sure. Oh, these are good ones. All right. It says the table above gives values of the differentiable functions f and g and their derivatives f prime and g prime at selected values of x. If h of x equals f of g of x, what is the slope of the graph of h at x equals 2? So basically what it's asking for is what is h prime of 2, right? I know that h prime of x is going to be f prime of g of x times g prime of x. Why do I know that? Very good. So now I'm just going to plug in 2. So g of 2 is -1. G prime of 2 is 2. F prime of -1 is 3. So I get 6. Yep. Sure thing. Because I had to do g of 2, which is -1,
Oh,
and then I did f prime of that result, right? Let me scoot through here real quick. Look for another good one here.
Good afternoon, remember it's 10:38 to be absolutely for that time. A big announcement from student council, I have the opportunity to vote for the freshmen.
Oh, it's okay. Yeah, I don't know. Be patient, because I'm not checking here. I do want to show you this one more if you're interested. You can go if you need to go, but just it's recording anyways, Age, if you want to go back and watch it. Right.
Everybody who ran for student council. Please watch for more information.
No, I didn't finish up with that. Oh, that's
And go Irish.
Okay. So I think she must have, but I didn't hear it. So this one is, again, if you have to go, go. Like, you can go. So I know that this is going to be, if I know that G and F are inverses, I know that like F of G of X is equal to X. And I know that,
Good afternoon, Dave Pratt.
I see. We're just,
Friday afternoon. Our
instead of
Tuesday
doing-
All Saints Day.
yeah,
And please take a moment, put yourself.
just
in
wasting
God's
more
presence.
time. I see.
Dear God,
The least
the
efficient way.
example of the faith who have gone before us. May we reflect on their faith and be inspired by their courage and determination. When we feel weak, help us gain the strength we need from the example of the saints, so we can respond to your call. Amen. Have a wonderful weekend, Northern Club. Good luck to our varsity soccer, our cross country this weekend, or tomorrow, I'd say, participate in the state championship. Go Irish, and God bless. Teachers, committees, and your students as you are ready.
Okay. So I know this, right? So would tell me that F prime of G of X times G prime of X is equal to 1. Or it would tell me that G prime of F of X times F prime of X is equal to 1. This is the first one's the one I want, because I can get the G of X or the G prime of X by itself, because that's what it's asking for in the problem. Okay. Now I have, okay, so if I want G prime of 2, I have 1 over F prime of G of, -2. Well, this wasn't as bad as I thought it was going to. I thought this was going to be a different one. So this is easy enough. I want to point out one other thing, though, here when I... So I guess it wasn't this problem, but at one point here, they give you the wrong... Instead of this, they had given you like F of 5 is equal to -2, which is not what you need. So remember that inverses, if I do like G to both sides, that would be 5 equals G of -2, right? That the inverse will cancel the other one out. So you might have to do that trick. I think there's one or two in the multiple choice where that happens. So just,
You just say it's inverse, like they're inverses of each other.
yeah. So think about it this way, right? Like if I have that, -2 goes to 5, and that's like f, g would take 5 back to -2, right? So if f of -2 is 5, then g of 5 is -2. So you think about it that way. Maybe that's the easier way to visualize it. Does that feel okay?
Yeah.
We would have to do this on the test?
Well, it was certain. I know that there's a multiple choice in there,
Okay.
and maybe I'm highlighting it because
Oh.
that particular one at least was in the consideration of ones to put on there. I can't remember for sure if it made the cut or not, but thought it would be a good one to point out. So if you're like, I have the wrong point, it's probably just because they did on purpose to make sure you understood that the inverse means that you can go the other, is doing the opposite direction.
Violet, you're missing a touch, right?
Is there going to be a visualization?
We're going to
Yes.
do that?
Yeah.
We have to know that formula?
Just the tangent line formula, but yeah, whatever you want to memorize it. But it's just the equation of a tangent line,
Thank you.
because that's what the formula is saying. Sure.
Thank you so much.
You're welcome.
Thank you.
Bye.